This video is going to demonstrate how to determine if an ordered pair is a solution to a system of linear inequalities, and it's also going to demonstrate how to graph a system of linear inequalities. So before we get going, please make sure you have these notes in front of you and fill them out as I go through it on this video. First thing to take a look at is examples numbers 1 and 2. Determine if an ordered pair is a solution to the given system. A ordered pair is a solution if, when you substitute it into each expression, you get a true statement. And we've already done this with equations, so we're going to do the same thing with inequalities. And we did it on yesterday's assignment. Now we're just going to plug it into two different inequalities. So remember that our first coordinate is our x and our second coordinate is our y. So let's plug x and y into the top expression. I would have negative 2 is less than 2 minus 3. And so that gives me that negative 2 is less than negative 1, which is true. Negative 2 is smaller than negative 1. So it works in the first one. Let's plug it into the second one. I'm going to have negative 2 is greater than negative x, which is a 2. So negative 2 plus 1. And so I end up with negative 2 is greater than negative 1. Well, that's false. Negative 2 is smaller than negative 1. So since it didn't work in both of them, that means that that ordered pair is not a solution for that system of inequalities. Let's try the second one. Let's plug in 2 for x. Let's plug in 5 for y. So let's plug it into the top one. I'm going to have 5 is greater than 2 times 2, which is 4. That's true. Let's plug it into the bottom one. I'm going to have 5 greater than or equal to 2 plus 2. And so I'm going to have 5 is greater than or equal to 4, which is a true statement. So since it works in both of them, that means that that ordered pair is a solution to that system of linear inequalities. On these next two examples, I'd like to demonstrate how to graph a system of linear inequalities. So let's take a look at problem number 3. What I notice when I look at the first inequality in number 3 is I notice that my slope, which I'm going to represent with the letter m, is negative 1. And the plus 4 tells me that my y-intercept is the point 0, 4. So let's plot the point 0, 4. And then my slope is negative 1. So that means I'm going to go down 1 and right 1. Make sure you can go down 1 and right 1 as many times as possible. Could also go up 1 and left 1 if you'd like. Now, before we draw the line in, let's decide if we're drawing a solid line or a dotted line. I'm going to look at my inequalities symbol. I do not see the equal to there, so that makes this a dotted line. So drawing a dashed boundary line. And then I have to decide where to shade. I'm going to again look at my inequality symbol. Since it is a less than symbol, I'm going to shade below. Now, I'm not going to shade anything yet. I'm just going to, in my mind, remember that I'm going to be shading below this line. And I might give myself like little arrows here just to kind of tell me that I'm shading underneath that line. Let's graph the second one. In the second one, my slope is equal to 1. That's the number that comes before the x. 0, negative 4 is my starting point. So let's plot that y-intercept. And then my slope is 1, so go up 1 and right 1. And I want you to continue to go up 1 and right 1 as many times as you can. Notice that we found where these two graphs intersect. If I was solving a system of equations, I would be interested in that point, which looks like the point 4, 0. Looks like this point right here. But with a system of linear inequalities, I'm interested in where the shaded regions overlap. Before I draw my line in, I say it's a less than symbol, so I'm going to draw in a dashed boundary line. Then I have to decide where to shade. Since it is a less than symbol, I'm going to shade underneath this line also. Now what I'm really interested in doing is shading where they overlap. And if you shade everything, that's fine. Just make sure that the overlapping area is darker. And this is the overlapping area down here. So it's less than both lines. Let's take a look at problem number 4. In number 4, I can look at this and realize that my slope is equal to 1 and that 0, 3 is my y-intercept. Let's plot that point first. 0, 3. My slope is 1, so go up 1 and right 1. You can also go down 1 and left 1 as much as you want, and I would encourage you to do it as many times as possible. I'm going to look at my inequality symbol. Since it is less than, doesn't have the equal to, it's just less than, I'm going to have a dashed boundary line. And now I have to decide where to shade. Since it is a less than symbol, I'm going to be shading underneath this line. I'm not going to totally shade it yet, but those arrows are going to remind me that I'm shading underneath that line. Let's graph the second one. My slope is equal to -2. And 0, 3 is my starting point. So let's start at 0, 3. Again, if I was solving a system of equations, I'd be interested in that first point because that's where things touch. But I'm not, because I'm interested in where the shaded regions overlap when I'm doing inequalities. My slope is -2, so go down 2 and right 1, and you continue to go down 2 and right 1 as many times as you can. We can also go up 2 and left 1. My symbol is less than or equal to. Since it has the equal to, I'm going to draw on a solid boundary line. And since it's less than, I'm going to shade below that line. So this would be below. So my final answer is making sure I have these two lines correct and then shading where the overlapping area is, which is this lower section of the graph.